Now that we're in lesson 24 through 25, we finally get to learn about linear systems. So we're going to start by graphing a couple of equations and taking a look at what that tells us. So first we want to start with graphing both of these equations right here. 2x minus 2y equals -4 and y equals a negative x minus 4. This first equation, because it's in standard form, we're going to graph using the intercepts. So if we're going to graph it by the intercepts, remember, we're going to cover one of them to find that intercept first. So if I want the x-intercept, I'm going to cover up y. I'm essentially going to take away y. 2x equals a -4, and that tells me that, well, 2 times what gives me a -4? That would be a -2. So x equals -2. There is a point where the line crosses the x-axis at -2, so right here. Next, we do it the other way, cover up x, and see what we got. So we have a -2y equals -4. Well, what times -2 gives us -4? +2 would. So the y-axis, it's going to cross at +2. So here we have a point, and now we have 2 points so we can draw our line. So this is the first equation. Now let's go ahead and graph the second equation. The second equation is y equals -x minus 4. That is in your y equals mx plus b form. That's your slope-intercept form. So we're going to graph it using the intercept and then go from there with using the slope to find a second point. Our starting point is the y-intercept, which on here is -4. So that tells us on the y-axis we start at a -4. And then the slope is -1, which tells us we can either think about going down 1 to the right 1, or you can think about going up 1 to the left 1. Either way, that's still going to give you that negative slope. And now that we have more than 2 points, we can draw our line. So here we've graphed both equations, and we can see that they cross. So the next it asks us, where do they cross? At what point do they cross? Well, they cross right here in the middle. So we have a crossing point right here at -3, -1. But why does that matter? Why would we care that they cross at -3, -1? What would be so special about that point? Well, if we remember back to thinking that every single point along a line is a solution to that equation, so everything along the black line is a solution to the first equation, and everything along the red line is a solution to the second equation, maybe where it crosses, this is a solution to both equations. Let's check it out. Let's see if that's true. So let's try the first equation. The first equation was a 2x minus 2y equals a -4. So I want to see if -3, -1 is a solution. And I'm going to do that by plugging them in. So we have a -3 for x, and we have a -1 for y. So that becomes -6. This becomes +2, and this is still -4. Does -6 plus 2 equal -4? Yes, it does. So that was a solution to the first equation. Let's check the second equation. The second equation was y equals -x minus 4. We have -1 for y, so -1 goes in for y. We have a -3 for x. We still have that -4. So we still have a -1. -3 becomes a +3 minus 4. So does -1 equal 3 minus 4? Yes, it does. So we just proved that that point where they cross is a solution to both equations. So let's take a look at what the actual definition is of linear systems, considering the fact that we actually just did one. So a linear system is a set of 2 or more linear equations. So if you have more than one equation, we call it a linear system. Now, in this level of math, you're mostly going to see just 2 equations being used for a system. In high school, you'll probably see a little bit more of 3 or 4, but you could have 1,000 equations. As long as you're graphing them together and finding that singular place where they cross, you have a linear system that you're working with. So then what's the solution to a linear system? The solution is where the lines cross. And we just saw that where the lines cross is a very special point. That is the point that is a solution to both equations. Last thing we're going to talk about is special solutions, because of course never anything in math is always going to be that simple. There's always going to be exceptions to the rule. So we're going to take a look at two types of special solutions. You might be thinking that you might already know what these are, considering there are two different types of special solutions to linear equations, so maybe linear systems are the same. Let's take a look. So I need to graph this system, 6x plus 3y equals 9. So if I graph by the intercepts, cover up y, we have a 6x equals 9, all right? Divide both sides by 6, and x equals, what is that, 1 1/3. So I'm going to come here, x is 1 1/3. Do the same thing for y, so I'm going to cover up x. 3y equals 9, well 9 divided by 3 is just 3, so it crosses y at 3. Now we have 2 points, but remember we might want to do a couple more just to make sure we're accurate, especially since we have one that's a fraction. So my slope is that I have to go down 3 to the right 1 1/3. So let's do that again. If I go down 3, I'm here, and then I need to go to the right 1 1/3. Well, 1 1/3 plus 1 1/3 is 2 2/3. So I need to go to 2 2/3. And this will make it so that my graph's a little bit more accurate to have 3 points, especially when I'm working with fractions. All right, so we have the first equation. Now we need to graph the second equation. So the second equation is also in standard form, so we're going to use the intercepts. 2x to cover up y, so we have a 2x equals 3. So if I want my y-intercept, I do 3 over 2, which is 1 1/2. So x crosses at 1 1/2. And then if I want my y-intercept, I cover up x, y equals 3. Something's looking a little special here. Well, I have my 2 points again if I wanted to do the same thing. Uh-oh. Something special is going on with this line. I ended up with the exact same line. Now, if I have the same line and my solution is where they cross, but they're on top of each other, aren't they crossing everywhere? So wouldn't everything be a solution? You're absolutely right. There is infinite solutions here because they are the same line. So because they are the exact same line, they of course have similar solutions all along there. So you're going to have infinite amount of solutions that can work in both of those. Let's take a look at one more special solution, but I bet a lot of you can figure out what it's already going to be. Here we have y equals 2x plus 6 and y equals 2x plus 3. So they are in slope-intercept form. If I'm going to graph this first one, I'm going to start at 6. 1, 2, 3, 4, 5, 6. And then my slope is 2, a positive 2, but I don't have room to go up. But I can go down instead. So remember, you just have to do 2 negatives to keep it positive. So I could go down 2 and to the left 1, because that keeps my positive slope. Down 2 to the left 1 keeps my positive slope. So now that's definitely enough points for us to have an accurate line. Let's draw that in. So we now need to graph the second equation. We have a y equals 2x plus 3. So since that's in slope-intercept form, we're going to start at positive 3. So the y-axis at positive 3. Then the slope is 2. So I'm going to go up 2 over 1, up 2 over 1, or I could go down 2 to the left 1 if I wanted to. And that's definitely enough points for us to draw a line. Let's draw that in. Something interesting is going on with this set of equations. They aren't crossing. Now, sometimes when this happens, it might be that I'm just not graphing the right part of the equation, but it doesn't look like they're ever going to cross because they're constantly the same distance from each other. There's a name for that. It's called parallel. And you can let me know if that's spelled wrong. So we have parallel lines, but the solution is where they cross. But parallel lines never cross. So I'm never going to have a solution. So there's no solution. Now, a fast way to figure out if there's no solution if the lines are parallel without graphing is by looking at the slopes. Parallel lines have the same slope. So if you're given this set of equations and you're supposed to graph it to solve, but you see right away that they both have the same slope, they both have the slope of 2, then you can already tell that it's going to be parallel and that it has no solution. So that's going to be a shortcut to not have to graph it if you see that right off the bat.